Hi, this is Team NASS, and we'll be targeting creating a website where to provide a marketplace service to all our users. The main components would be the user service, the item service, the contact info service, the order service, as well as a composition service to align the users and contact information services. So we'll quickly showcase our cloud architecture, then followed by a live demo, and then three main parts of the system, mainly the front end, the gateway, and the authorization, as well as the backend, and finally over the project management, which we're done. So if you look at the cloud architecture, we have the various clients which are served the application, and we have an API gateway which acts as an interface between the clients as well as our microservices. The API gateway also interacts with the Google Identity Services to figure out which client had sent in the request, which has to be forwarded to each of the microservices. So our front end is hosted on AWS Amplify, and which is again on ECS, and we also have a CloudFront on top of the AWS Amplify. And if you look at the microservices, we have the order service, which is a Docker container, which interacts with the DynamoDB key value store. We then have the item service, which is hosted on Beanstalk, which interacts with the items DB. We have the order service, user service, contact service, and then a composition service, which composes users and contacts. And finally, we are using a couple of Lambda functions to do the email verification, and an S3 bucket for packages for the Lambda functions, as well as using CI/CD for the code pipeline and the deploy as well. So let's have a quick live demo by Austin.
All right, this is the live demo of our application. Teja is currently on the home screen dashboard where you can browse through all the items in our marketplace. You can use pagination to go between different pages of items. And now we're gonna have Teja log in for the first time. He's gonna be prompted to log in with Google, where he will enter his credentials. After that, Teja is redirected back to our home screen, which then redirects him to the sign-in page so he can enter all of the required information for our microservices to make a new user. After submitting, he's finally created a new user, and at the top right here, you can see his image is shown, and he can go to his profile page where it shows all the personal information and all the items he has for sale and the items he's interested in. So Teja's going to post a new item right now. This brings up a form where he can post a new item to our microservice. After the item's posted, he's redirected to the page for that item. Now Teja's gonna go back to his profile page and see that his user-specific items are showing of the ones that he's selling. Teja can probably also take this time to update the profile. So he's gonna go back to the profile page and go to update profile. This works very similarly. So he's gonna change his first name and hit submit. And you can see the profile is updated in the backend. Teja's now going to browse some items, and let's say he wants to buy these sneakers. So he's going to click contact buyer, which two things will happen. First, an email will, a pre-filled email will pop up to email the buyer that they're interested in, and also the order will be logged. Now, if Teja goes back to his profile page, you can see a log of items that he's interested in, and he can click on those logs to go back to them. When Teja made an account, an email was sent to verify his account. So we're going to check. Sometimes the emails take a little longer to send, but we checked, and there's the email verification. So now we can mark Teja as a validated user.
Yeah, now we'll discuss the three main parts of a system, starting with the front end. So a quick refresher, this is the UI home. We see that it is hosted on Amplify. And if you look at the various features the home supports, we have the pagination, items list, and support for images hosted on Amplify. We have the dark mode as well, and we have a Google login, as well as support for searching for a particular item. If you look at the profile page, we are listing the user items, the update profile form, as well as the interested items as well. A detailed item view where we can contact the buyer through an email and also mark an item as interested. And finally, we also have a couple of forms to update the user profile information, which is pre-populated as well. So we have hosted our front end on AWS Amplify, and this is the Amplify dashboard. Amplify also provides us with continuous deployment of the UI, as well as we have registered our application with Google Auth so that the OAuth services work with our application once it's hosted on Amplify. So this is the Amplify dashboard. We see that it has been provisioned and built and successfully deployed as well. So I'll quickly open the app, which is hosted on Amplify, and we see the home page loaded up. And yeah, here's a page where I'm signed in, and it's hosted on Amplify. Similarly, we have used CloudFront, which gives us this dedicated CloudFront URL over the CDN on AWS. Now we'll have a quick look at the gateway and the detailed look at the authorization, which we have done. So our API gateway interacts with all our microservices. It also takes care of parsing the query parameters and understanding the request body structure, and connects the Lambda functions of the authorization, which does the authentication and authorization of the user through the JWT token, which is sent as a header from the clients. And once it contacts Google to figure out which user it is from the JWT token, it adds the headers of CID, which is the customer ID, the email, as well as the roles of the user, which will be used by the microservices further downstream. So these are the various gateway paths on the right, and on the left, we see a test response of a particular API to the AWS gateway. So a quick view at the gateway. So this is the API gateway functions, and this is a Lambda authorization function, which we have defined here. And these are the headers, which are part of the integration through the gateway. So we can do a quick test here. So we can use the items microservice and fetch the list of items here, and we see that the request body works and it was hit through the gateway. So we are doing the Lambda authorization where each request goes through this Lambda function, which does the authorization for us through the API gateway. And if we have a quick look at the authorizer code, we see that we are interacting with the Google APIs to parse the JWT token and further send out the CID and the email further downstream. So if you look at Google login in the front end, our app is registered with GCP, as we see on the image on the right, where we have specified our Amplify URL. And we also have added support for refresh tokens, where once the token expires in the front end, we automatically refresh the token and use the updated token for interacting with the gateway. Interaction with Google is on the left, and what it gives us is this access token, which is sent out as a JWT token header to the gateway, and the gateway uses this Google API to figure out what is the particular user ID and the email of the user, instead of relying on the data being filled by the user, which is even more secure. Switching gears to discussing about the backend. So first we'll discuss about the verification email backend. Here on the left, we see the email which we had received from our NASS email verify address. If the user is verified, we see that the user has a verified user success message. And we also added checks to see that if the user is already verified, then no action is needed. So these emails are sent out and the verification is triggered basically by these two Lambda functions. We have an SNS queue where the contact service pushes a notification to which updates SNS, which again further triggers the Lambda downstream. So SNS, this is the topic which we had created, which is email verify, and this is the ID of that particular topic. And these are the two Lambda functions which we had created. The first Lambda function, which is triggered by the SNS, sort of generates the URL link for us, which is emailed to the user. And the second Lambda function, the URL is clicked in the email, the gateway is triggered, and then runs the confirm function, which updates the database. So a quick look at the Lambda functions. So this is the create email verify Lambda, where we use the NASS email verify gmail.com to send out the email. Here is the URL, which is being created once at the end of the Lambda function. And this is the second Lambda function, which is triggered when the URL is clicked. Basically, we are using the random salt user and the user ID to figure out which user has sent out the request and then update the database from here. So we are using an S3 bucket to use all the packages which are required by the Lambda functions. So we have three separate databases to service our application. So one is the contacts database, which has all the contact information. One is the items database, which has the information of all the items. And then we have the customer database, which all the customer information. So we have four microservices, three of which are hosted on EC2, and we have the items microservice, which is hosted on Beanstalk. And all of these microservices expose modular RESTful APIs. So this is the first microservice, which is items, hosted on Elastic Beanstalk, as we see on the right. And on the left is one of the sample APIs, which we see for the items microservice. We have the orders microservice, which is in this Docker container, as we see on the top. And we have this by item API being exposed, as we see here, which helps us to place orders for this items. We then have the contact info microservice. So here we see a glimpse of fetching the contact information, where it shows along with pagination and respective self-describing links as well. So here we have the orders microservice, which is hosted on EC2. So this orders microservice uses DynamoDB here, so which stores the key value tuples of order ID to the respective order. Next, we have the customer contact, which is a composition microservice. So this microservice interacts with both the contacts as well as the customer microservices to allow us to add information or fetch information for a particular customer. So here on the left is a glimpse of the contacts compose output, where we see the self-describing links being populated. We are asynchronously hitting both the customer's URL as well as the contact's URL at the same time, and then waiting for both the results to be done. So we are also doing Smarty API address validation on the microservice level itself. So quick overview of the REST APIs. So we have the well-designed paths as well as respective links for each APIs. We also have a complete functionality of get, put, patch, and delete for each of the APIs, and all are clearly serializable and also have proper response codes like 200 and 400 and so on. If there are any conflicts, we also have conflict responses where respective error codes are also provided. And we also support filtering of APIs as well, where here we are fetching only the email of that particular user, and all are readable and detailed responses as well. We also are added a little bit of middleware, authorization middleware to our REST APIs, where the microservice middleware takes care of role-based access model, where we have particular roles like super user, admin, and so on, who can access all the information or delete all the information. So the way this was implemented was with the help of this block, where we check if the user is the valid, like updating his own information, or if he is not an admin user, then it's forbidden. So we also have Swagger pages enabled for all our microservices. So switching back to the browser, so this is the items microservice, where we are fetching the list of all items being served right now. And we see that it has self-describing URLs as well. And we also have the list of pages, and we can switch to the next page as well. So if we click on the customer link here, we in turn hit the information to fetch that particular customer, which is again self-describing as well. And we can go back to the items for that particular customer as well by clicking on that link. We also supported search for particular items using some search queries, which are RESTful API support. So here we are searching for a tiger in our items. So if we click, we'll get items which satisfy that particular query as well. So we have done same things for similar other microservices as well. So this is the orders microservice, which is serving the list of orders. We also have our Swagger UI being served over our endpoint. So we have the fetching the list of items here. So if we quickly try out the UI, So these are the list of items which is being served on Swagger as well. So now quickly go over the project management aspects. So we have used CI/CD pipelines to quickly deploy our code to production. So here's a quick glimpse at the code pipeline where we are deploying our customer composite microservice to production, where we see that this was the last succeeded build which was pushed and served as well. So similarly, we have been pushing the front end using AWS Amplify, which is taking care of the continuous deploys for us. Finally, we have used GitHub projects to for track our scrums and our progress. That's the end of our presentation, and thank you, Professor and TAs, for your time, and happy holidays.